Hello, welcome back to mechanics, where we're looking at motions in 1D. So let's see. Since we have all of this information, we know what motion is. We've looked at different types of motions. We've defined position, velocity, and accelerations. What do all of these terms mean, and what is the relationship between them, right? So now we've also looked at equations of motion. So now let's just look at what is the problem solving strategy that is effective in solving these equations, right? Let's say you're given a question in motion. How do you solve it, right? So let's just look at it this. So number one, um, draw a diagram. You want to draw a diagram of what you're given, right? They will say a car is accelerating from point A to point B, right? You draw that diagram, right? So I'll give you an example of how a diagram looks like. So let's just move to the next step. The next step is show given information or indicate given information at all stages. All right. Indicate given information at all stages. So what does indicate given information at all stages mean? It means that, let's say for example, you start at rest. Okay, what do you have at rest? What's your velocity? What's your displacement? What's your acceleration? What's the time? Okay, you move and then they say after, let's say, 400 meters, there's a change in speed from 10 meters per second to 15. Okay, at that point there was a change in stage, right? From 10 to 15. You give your information there. What was the distance? What is the displacement? 400. What is the speed? What is the time, right? So indicate all of the information for that stage. And then when there's a change, for example, the car starts slowing down now. What happens in that stage? Give you information, indicate on the diagram, right? So that's what it means. So number three is choose a positive direction. Okay. So this could be a direction in which your object is moving, which is ideal, right? Choose a positive direction. If your object is moving to the right, you can choose to the right as a positive direction. Sometimes you can just use a Cartesian plane and indicate that as your x-axis to the right, which is positive. Or if it's it's a vertical problem. Let's say, for example, it's moving up and down. You can indicate up as your positive, or you can indicate down as a positive. But down as positive is ideal. Why? Because of your force that's acting on the object. Gravitational force is always down. So if you are aligning with gravitational force, it means you're aligning with acceleration, right? If you're moving down. So you can take positive as down. Sometimes some people separate the stages because when you go up, right, you have to come down. So when they go up, they have a positive direction, and then when they come down, they change directions and have down as the positive direction. I'll just say choose one direction. It's much better that way, right? It's not confusing, and also by indicating each and every information, right, this will allow you to choose the correct equation, right? The correct equation, or these are equations of motion, right? Because all of those equations were four. Sometimes one on those equations have around three parameters. You have sometimes they have four, right? Where you have displacement, you have speed, you have acceleration, and you have time. But in some cases, you only have three unknowns, right? So choose ones that you know. Let's say, for example, you're given the speed and velocity, right? You want to find time. You cannot choose one that has four unknowns, right? You have to choose one that has three unknowns, that has what you're given, so you can solve what you don't know. So you have to choose the correct equation by knowing what you are given, what is the given information, right? And also um, by choosing the correct equation. So this goes along with um, what is this? indicate what is required, or desired information. So this is what you find from the equation, right? Calculate time or what. Then this allows you to do what? To choose a correct equation along with the given information, right? So that's what you have. And then at the end, when you're done, you have to do what? Make sure that your final answer has units and direction. And answer always have units and direction. We're dealing with vectors here, right? So you need your units and you also need direction. So this is your problem solving strategy, right? So let's apply this on a question, right? But before we get to that we get to applying this, let's just take a detour and look at the common phrases that I usually use when you look at questions in motion, right? So what are these common phrases? So let's just look at them. These common phrases are very useful actually. You will know what they mean, and then when you know what they mean, you know what to do, right? Because these are usually given information, but rather in phrases. So let's say, for example, they say the object is starting from rest, right? Starting from rest. What does this mean? It means that the initial velocity is equal to 0 meters per second. And then when they say it comes to a stop, okay, comes to a stop, it means that the final velocity is equal to 0, right? It comes to a stop, it stopped, it was slowing down and then it stopped, right? And then the third phrase is slowing down. We've already looked at slowing down in part 1, and let's also take this with speeding up, right? Slowing down, it means you have a negative acceleration, right? So your acceleration is negative. Speeding up means you have a positive acceleration. We can also look at this one. We've also touched on this one where you have constant velocity. So every time when they tell you that you have a constant velocity, what they're telling you is that it's a green light for your equations of motion, because you have what? Yeah, yeah, you can use the equations of motions, because this means what? You have zero acceleration, right? Which is the same as constant acceleration. Actually similar to constant acceleration because it's not changing, right? So this is what you have, right? Constant velocity means zero acceleration, speeding up, positive acceleration, slowing down, negative acceleration, comes to a stop, uh, final velocity zero, starting from rest, initial velocity is zero. And if they say it's at rest, they mean that velocity is zero, right? So let's also look at units conversion. So units conversion. Let's say we want to convert meters per second to kilometers per hour, or kilometers per hour back to meters per second, right? So how do we do it? So for example, let's say if we wanna move from meters per second to kilometers per hour, so let's look at that. So here, meters over second, let's multiply by what? So 1 kilometers, right? So let's what is 1 kilometer equal to? So we have 1 kilometer, it's equal to 1000 meters, right? Multiply by what? hours at hours at the bottom and second. So we'll have 1 hour. 1 hour is equal to how many seconds? It's 3,600 because you have 60 minutes in 1 hour, but in 1 minute you have what? You have 60 seconds. So you have 60 by 60. So this gives you 3,600 seconds. And seconds crash out with seconds, meters crash out with meters. So we'll have what? 3,600 over 1,000 kilometers hour. This is 3.6 kilometers per hour, right? So therefore 1 meters per second is equal to 3.6 kilometers per hour, right? So this means that 1 kilometer per hour is equal to 1 over 3.6 meters per second. So you will have to multiply by 3.6 if you are given in meters per second, divide by 3.6 if you are given kilometers per hour. So for example, if you are given that your velocity is equal to 100 kilometers per hour, you just do what? You just divide this by 3.6. What you get, it gives you 27.77. So 27.7, is it 77 or 78? It's 78. 27.78 meters per second. Multiply by this by 3, you get that 100 kilometers per hour. So that's your unit conversion. So that's how it works, right? So let's see. Let's look at our example. Actually, let's end the video here, and then we'll look at our examples on a different video that will be much better, so that we don't have to prolong the video to around 30 minutes, so that it's easier to watch. Right? Thank you.